Space appears empty, cold, indifferent. Humanity has grown accustomed to thinking of it as a distant backdrop, a dark stage on which the story of Earth simply unfolds. A vast void that seems to have little to do with everyday life. But in reality, space determines everything. It defines the conditions under which a planet, an atmosphere, life, and intelligence can exist at all. Earth did not appear by accident, but neither was it designed. It formed within an extremely narrow range of parameters, the right distance from its star, a stable orbit, a magnetic field shielding the surface from lethal radiation, and an atmosphere capable of retaining heat. For billions of years, these conditions remained almost unchanged, for so long that humanity accepted them as permanent. But in the universe, nothing is permanent. There are only temporary states. Space has no obligation to preserve conditions that are convenient for life. It does not recognize planets, civilizations, or species. It obeys processes whose scale lies far beyond human perception. And when those processes begin to affect Earth, they do so quietly. No explosions. No flashes in the sky. No warning. Everything begins with numbers. In observatories around the world, astronomers start recording data that, at first glance, seems unremarkable. Satellite orbits deviate slightly from predicted values. The length of a day changes by fractions of a millisecond. The moon drifts away from Earth just a bit faster than existing models allow. These deviations are so small that, for decades, they could have been dismissed as measurement error. But the problem is that the errors begin to agree. Different instruments, different countries, different calculation methods. And the same result: Earth is no longer behaving the way it should. Scientists remain cautious. Science does not tolerate hasty conclusions. Any anomaly must be verified, recalculated, and then doubted. Computer models are rebuilt. Corrections are added to equations. Solar activity, atmospheric interference, calibration flaws, everything is blamed. Yet the data keeps accumulating. Gradually, it becomes clear: the source of the changes is neither Earth nor the Sun. It lies outside, in the space surrounding the planet itself. Space is no longer a passive medium. At some point, an idea emerges that initially sounds absurd: the properties of the vacuum near Earth are changing. Emptiness is no longer truly empty. It seems to resist motion, however slightly. This contradicts the very foundation of modern physics. Vacuum is the baseline of all calculations. If it changes, everything changes. And that is exactly what is happening. Earth keeps rotating. People go to work, launch satellites, record videos, unaware that the planet has already entered a process that cannot be stopped. A process with no intention, no hostility, and no awareness. Space is not attacking Earth. It is simply no longer the same. And at that moment, the slow destruction of the planet begins. Without war. Without an enemy. Without any chance of victory. At first, no one calls it a discovery. What is happening does not look like a breakthrough or a revelation. It looks like noise. Like statistical dust, the kind that scientists are trained to ignore. Every instrument has limits. Every measurement contains uncertainty. And space, especially space, is full of variables that are still poorly understood. The anomalies are too small to cause alarm. A satellite requires slightly more correction fuel than planned. A probe arrives milliseconds later than predicted. Atomic clocks, synchronized across continents, begin to disagree by almost immeasurable margins. These are not failures. They are inconveniences. Annoying details buried deep inside technical reports. For months, the data circulates quietly. Engineers adjust algorithms. Astrophysicists recalibrate sensors. Software updates rewrite error margins. Each anomaly, when viewed in isolation, has a plausible explanation. Solar wind fluctuations. Gravitational noise. Instrument aging. Human oversight. Science moves slowly for a reason. Extraordinary claims demand extraordinary evidence. And there is no extraordinary evidence, only persistence. The deviations do not disappear. They return again and again, always subtle, always consistent. The equations still work, but only after additional corrections are applied. Models still function, but they now require assumptions that did not exist before. Invisible terms begin to appear in calculations, placeholders for something unnamed. One pattern becomes increasingly difficult to ignore. Objects moving through near-Earth space behave as if they are losing energy. Not abruptly, not dramatically, but continuously, as though space itself is exerting a gentle, universal drag. This should be impossible. Vacuum has no friction. Empty space does not slow motion. These principles are not theoretical preferences, they are foundations. If they are wrong, physics itself is incomplete. A handful of researchers begin comparing independent datasets. Orbital decay rates, laser ranging experiments, deep space telemetry. When the numbers are placed side by side, a disturbing coherence emerges. The discrepancies align. Different missions, different agencies, different decades. The same invisible resistance. The shift is not localized. It does not originate from a single source. It does not radiate from a point or move like a wave. It exists everywhere around Earth, evenly distributed, as if the planet has entered a region of space with slightly altered properties. No sensor is designed to measure that. The instruments can only see the consequences, never the cause. Attempts are made to quantify the effect. New parameters are introduced. Experimental constants are proposed, then abandoned. Each estimate contradicts another. The uncertainty remains larger than the signal itself. That is when concern begins to replace curiosity. Because the effect is not fading. Year after year, the required corrections grow. Navigation systems become more complex. Mission margins shrink. Spaceflight near Earth becomes less predictable, not because of chaos, but because of consistency. Something stable has changed. And stability is far more frightening than randomness. Behind closed doors, an unspoken question circulates among scientists. What if this is not an error? What if this is not a temporary fluctuation? What if the space around Earth is no longer the same space humanity learned to understand? No one publishes that question. Not yet. Because to acknowledge it would mean accepting a reality where the most basic assumptions about the universe are no longer reliable. And science, like civilization itself, depends on the belief that the ground beneath its equations does not move. But it is already moving. So slowly that no single experiment can capture it. So quietly that no alarm is triggered. And yet, the shift continues. Invisible, unmeasurable, and unstoppable. Chapter 3. The Sun Loses Its Rhythm. Voiceover. For centuries, the sun has been humanity's most reliable constant. It rises. It sets. It burns with near-perfect regularity. Entire civilizations were built on the assumption that the sun's behavior, while complex, follows stable cycles that can be predicted, measured, and trusted. That assumption begins to fail quietly. The first signs appear not in visible light, but in long-term solar data. Space-based observatories record subtle irregularities in the sun's output. Not dramatic drops. Not violent flares. Something far more unsettling, a loss of rhythm. Solar cycles still exist, but their timing drifts. Peaks arrive too early or too late. Valleys linger longer than expected. The total energy emitted by the sun remains nearly the same, yet its distribution changes. More bursts. Less continuity. The sun is no longer pulsing like a steady heart. Heliophysicists search for explanations. They blame internal magnetic turbulence, plasma instabilities, long-period oscillations deep within the solar core. Models are adjusted to include rare but natural variations. The math still works, barely. But something does not fit. Solar wind measurements reveal a persistent anomaly. The stream of charged particles flowing outward from the sun shows signs of resistance. Not collisions. Not scattering. A gradual loss of momentum, as if the particles are pushing against an invisible medium. That medium should not exist. Between the Sun and Earth lies near-perfect vacuum. Nothing dense enough to slow particles traveling at hundreds of kilometers per second. And yet, the slowdown is measurable. Barely. But consistently. As the solar wind weakens, Earth's magnetic field responds. At first, the effects are subtle. The magnetosphere compresses slightly. Auroras appear at unusual latitudes. Satellites experience unexpected charging events. These are treated as isolated incidents, curiosities rather than warnings. On the surface of the planet, the consequences are indirect, but growing. The upper atmosphere begins to cool. Its density shifts. Drag on low-orbit satellites increases unpredictably. Weather models struggle to reconcile new patterns forming in the jet streams. Seasons lose their familiarity. Summers stretch longer but feel less intense. Winters arrive late, then strike sharply. Temperature gradients steepen. Storm systems behave erratically, not stronger, just less organized. Biological systems notice before humans do. Migratory species drift off course. Insects emerge at the wrong times. Ocean currents subtly realign, altering nutrient flows that ecosystems depend on. These changes do not cause immediate collapse. They cause confusion. And confusion spreads. The sun still shines. That is the most dangerous part. Because nothing looks broken. Governments do not react. Markets remain calm. Life continues. Headlines focus on short-term crises, not slow cosmic trends that unfold over decades. But among a small group of researchers, a new idea begins to take shape. The sun is not changing on its own. It is responding. Responding to the same invisible shift affecting Earth's orbit, its satellites, and the surrounding vacuum. The space between objects is no longer neutral. It is beginning to interact. Not violently. Persistently. The sun is losing its rhythm not because it is dying, but because the medium through which its energy travels is no longer the same. Light still reaches Earth. Heat still arrives. But every photon, every particle, now passes through a space that subtly drains coherence. The effects compound. Slowly. Silently. And irreversibly. For most of human history, space was imagined as emptiness. A void. A nothingness separating worlds. Modern physics replaced that idea with something more precise. A vacuum filled with fields, probabilities, and virtual particles. But despite its complexity, one property remained unquestioned: space did not resist motion. Objects could drift forever without slowing down. Momentum, once gained, was preserved. That principle begins to fail near Earth. Not suddenly. Not catastrophically. At first, the signs appear in mission reports no one outside aerospace engineering ever reads. Low Earth orbit satellites require more frequent corrections. Tiny bursts of thrusters that should not be necessary. Fuel reserves deplete faster than planned. Engineers attribute the issue to atmospheric drag, solar activity, minor modeling errors. But the atmosphere cannot be responsible. The drag is present far above where air should exist. At altitudes once considered perfectly clean vacuum, spacecraft experience resistance. Not turbulence. Not collisions. A smooth, continuous loss of velocity, as if they are moving through an invisible fluid. Orbit by orbit, the effect compounds. Satellites designed to last decades begin to decay years early. Trajectories that once remained stable now require constant intervention. Mission planners quietly increase safety margins, unaware that no margin is sufficient. Because the resistance is not random. It is uniform. Laser ranging experiments confirm it. Highly precise beams fired between Earth and orbital reflectors return with delays too consistent to ignore. Time of flight measurements reveal something unsettling. Light itself is behaving as though space has become slightly denser. Not enough to see. Not enough to feel. But enough to measure. The word viscosity enters internal discussions. Not officially. Not publicly. Because vacuum is not supposed to have viscosity. If it does, then motion through space is no longer free. Every orbit, Every rotation, every flow of energy now pays a cost. Earth is no exception. The planet plows through space at tens of kilometers per second. If the medium around it has changed, even slightly, the consequences are enormous. Earth begins to lose rotational energy. Days grow longer by imperceptible fractions. Tidal interactions shift. The delicate gravitational dance between Earth and Moon subtly changes, altering stresses within the planet's crust. Deep underground, the mantle responds. Seismic activity increases, not in violent spikes, but in frequency. Small earthquakes become more common. Volcanic systems show signs of restlessness, as heat transfer within the planet becomes less efficient. Above the surface, spaceflight grows dangerous. Docking windows narrow. Orbital predictions drift. Automated systems compensate more aggressively, masking the problem, but only temporarily. Then come the failures. A satellite misses its correction burned by milliseconds and enters an unrecoverable decay. Another tumbles after its attitude control system overcorrects against resistance it was never designed to fight. Each failure is investigated separately. No one wants to connect them, because connecting them means accepting something unprecedented, that the vacuum surrounding Earth is no longer empty in the way physics requires it to be. The planet is moving through a medium that did not exist before. Or worse, a medium that always existed, but has only now begun to interact. Whatever the cause, the conclusion is unavoidable. Space around Earth has become viscous. And friction, once introduced, never stops taking energy. It only takes time. As long as the evidence remains close to Earth, uncertainty feels manageable. Local problems suggest local causes. If something is wrong near the planet, then perhaps the planet is responsible. Perhaps the Sun. Perhaps a rare alignment of forces that can be modeled, isolated, and corrected. That assumption survives until information arrives from a place where Earth has no influence at all. Far beyond the edge of the solar system, where sunlight weakens into background glow, a deep space probe continues a journey begun decades earlier. It carries no cameras for beauty, no instruments for discovery headlines. Its task is modest and precise: to describe the environment between stars exactly as it is. For years, nothing unusual appears. Interstellar space behaves as expected. Particle densities remain low. Radiation follows predicted distributions. Magnetic fields fade into near absence. The data confirms what physics has long assumed: deep space is stable. Then stability begins to erode. The probe's predicted position and its actual position begin to diverge. Not abruptly. Not dramatically. At first, the difference is smaller than the length of the spacecraft itself. Analysts blame numerical rounding, clock synchronization drift, thermal distortion of the probe's structure. But the discrepancy does not reset. It grows. With each transmission, the probe arrives where it should not be, slightly behind its expected path. Reconstruction of its trajectory reveals a steady loss of velocity. No engines fire. No collisions occur. No gravitational bodies are present. In interstellar vacuum, motion should persist indefinitely. Yet the probe slows. When this behavior is compared with orbital decay data from near-Earth satellites, the resemblance is impossible to deny. The curve is the same. The rate is the same. The character of the loss is the same. What affects Earth's immediate surroundings also affects the space between stars. The conclusion is devastating in its simplicity. Earth did not enter a disturbed region of space. The region expanded to include Earth. Archived data deepens the shock. Earlier transmissions show the effect in its infancy, present, but buried beneath noise. The probe did not encounter the phenomenon at a boundary. There was no boundary. The change occurred everywhere, gradually, uniformly, without a front or direction. Inside scientific institutions, the tone of discussion shifts. Words like error and anomaly quietly disappear. They are replaced with language reserved for irreversible change, transformation, reconfiguration, a new equilibrium. This is not the end of motion, nor the collapse of structure. Stars still shine. Galaxies still rotate. But every movement now carries a subtle cost. Energy dissipates where it once conserved. Momentum fades where it once endured. In such a universe, survival is not a matter of resistance, it is a matter of expenditure. Earth reacts first not because it is special, but because it is complex. Complex systems reveal failure before simple ones do. The probe continues its silent drift, transmitting until its power source weakens beyond recovery. When the signal finally ends, it leaves behind a conclusion no calculation can soften. This is not a danger approaching from afar. It is a condition that now defines space itself, and everything within it must obey. As the realization of a viscous, interactive space sinks in, scientists confront an even more unsettling truth. The anomaly is not limited to position, momentum, or energy loss. It hints at something deeper, something fundamental. The laws themselves may be bending, not violently, but imperceptibly, over vast stretches of time and space. Physical constants that have governed matter for billions of years, the speed of light, Planck's constant, gravitational strength, appear to fluctuate within undetectable margins. Too small for casual measurement, but consistent enough to skew highly sensitive experiments. Particle interactions in distant laboratories begin showing tiny deviations from predicted outcomes. Atomic decay rates shift. Electromagnetic propagation subtly distorts. At first, the discrepancies are dismissed. Equipment malfunction, measurement error, human oversight. But the patterns grow impossible to ignore. Independent labs on multiple continents report the same irregularities. Calculations, replicated endlessly, reveal a disturbing truth: the universe itself is changing. These changes are not catastrophic in the immediate sense. Stars still ignite. Planets continue to orbit. Galaxies maintain their shape. Yet the framework underlying their existence, the rules that guarantee stability, is no longer absolute. Every action carries a hidden cost. Energy, once preserved in predictable ways, begins to leak. Momentum fades. Forces that define motion lose their constancy. Scientists struggle to adapt. Theoretical frameworks are rewritten. Constants become variables. Equations once considered universal are now local approximations. Models that once predicted cosmic behavior with uncanny accuracy now require correction factors that feel more like patches than solutions. The implications ripple through civilization. Satellites require new calculations for orbital insertion. Communications experience unexplainable delays. Particle accelerators struggle to achieve previously routine outcomes. Technologies dependent on precise constants begin to fail subtly, then accumulate errors that compound over time. The philosophical impact is profound. Humanity has always relied on the stability of the cosmos as a foundation for understanding reality. If the universe is changing, even slowly, that foundation is gone. Cause and effect, predictability, and even the concept of time itself feel uncertain. Researchers attempt to map the effect. Graphs, simulations, and models illustrate a universe in slow flux. There is no direction, no gradient, no identifiable source. The changes are everywhere, yet imperceptibly distributed. A cosmic background of uncertainty, invisible, uniform, and persistent. This knowledge spreads among a small community of scientists and thinkers. The public remains unaware. Ordinary life continues unchanged, blissfully ignorant. But for those who understand, every calculation, every plan, every expectation carries the unspoken acknowledgement that reality is no longer fixed. The universe is still magnificent. It is still full of light, motion, and wonder. But every photon, every particle, every wave now moves through a medium that is subtly different than it was a generation ago. Stability is no longer guaranteed. And humanity's role, once secure, is now defined by adaptability, vigilance, and an ever-increasing expenditure of energy just to maintain the patterns of life. Time, motion, and matter all bear the cost of a universe that has begun to change from within. As the invisible changes in space and the subtle shifts in physical laws propagate, Earth begins to show signs of straying. The effects are not dramatic, not catastrophic in the immediate sense, but they accumulate quietly, steadily, and universally. The atmosphere, previously stable, begins to respond to these imperceptible shifts. Wind patterns lose predictability. Jet streams meander in unusual paths. Weather systems develop minor anomalies that cannot be explained by solar cycles or ocean currents alone. Seasons lose their usual rhythm, and ecological cues become unreliable. Biological systems are the first to react. Migratory birds arrive too early or too late. Pollination cycles fall out of sync with plant flowering. Insects hatch at incorrect times, upsetting local food chains. Marine life notices subtle changes in currents and water density, altering the distribution of nutrients. Species do not die immediately, but the cumulative effects create confusion, stress, and misalignment within ecosystems. Even human activity feels the strain. Agriculture struggles with unpredictable weather. Power grids contend with slight fluctuations in solar radiation. Satellite-dependent systems, from GPS to communications, encounter growing inconsistencies. Engineers and planners find that established calculations are no longer perfectly reliable. Small deviations become frequent, but no single failure explains the growing pattern. Seismic activity and geophysical processes respond to the planet's slow loss of rotational energy and the subtle gravitational shifts. Small tremors increase in frequency. Volcanic systems show signs of abnormal restlessness. Oceans experience subtle shifts in currents, tides, and temperature distributions, affecting coastal and marine ecosystems. Human perception, however, lags behind the changes. Life continues with a semblance of normality. People notice anomalies, unexpected storms, unusual animal behavior, technical malfunctions, but they are treated as isolated incidents. Only a few scientists, aware of the larger cosmic context, understand the true scale of the problem. The planet itself is not dying, but it is under constant, invisible pressure. Every rotation, every orbit, every movement now carries a hidden cost. The natural systems that have maintained life for millennia are forced to expend more energy just to maintain their previous rhythms. Civilization continues, but it does so on a planet that is subtly, consistently different from the one humanity has known. A planet where the cost of stability grows steadily, imperceptibly, and universally. And the people who notice first understand one fundamental truth: the challenges ahead will not arrive as sudden disaster, but as slow, relentless change that tests endurance, adaptation, and the very definition of life on Earth. As Earth's environment struggles under invisible pressures and the universe itself begins to shift, human technology begins to strain under the same unseen forces. Machines, satellites, and infrastructure that once operated flawlessly now behave unpredictably. The change is gradual but relentless. Communication networks experience inexplicable delays. Signals between continents occasionally drift out of synchronization. Satellite constellations that maintain global positioning falter. Navigation systems, once precise to the centimeter, begin to misalign by meters. Engineers scramble, recalculating trajectories, adjusting code, and rebooting systems, but each correction is temporary. Power grids feel the stress. Solar and wind farms, reliant on predictable environmental inputs, generate inconsistent energy. Electrical systems experience micro-fluctuations. Transformers overheat. Blackouts occur in isolated regions, dismissed at first as routine malfunctions. Transportation systems, from aviation to shipping, rely on technology now subtly altered. Flight paths deviate. GPS guidance falters. Automated shipping systems arrive late, sometimes off course. Failures are rare but grow in frequency, creating a creeping uncertainty in day-to-day life. Manufacturing and industry are not immune. Precision instruments fail to meet tolerances. Assembly robots falter in their calibration. Even basic measurements of mass and distance require repeated verification. Factories begin introducing redundancy and manual oversight, increasing costs and slowing production. The response is adaptation. Humanity learns to compensate. Engineers design new protocols that can adjust for unpredictable physical constants. Satellites are equipped with extra fuel and correction algorithms. Power grids integrate more flexible systems, capable of rapid response to fluctuations. Factories implement continuous recalibration routines. But adaptation comes at a cost. Efficiency declines. Resource consumption increases. The margin for error narrows. Every system requires more energy and attention just to maintain previous levels of functionality. For the first time, the connection between Earth and the cosmos becomes undeniable. What was once theoretical, the subtle influence of space on matter, now touches the core of civilization. The universe is no longer a distant backdrop. It is a participant. Every orbit, every energy flow, every technological operation carries the weight of unseen cosmic forces. Civilization is resilient, but it is no longer free. Every advancement, every convenience, every calculation now contends with a universe that has begun to change from within. Humanity adapts, but it adapts into a world that is subtly but irreversibly different. Despite the growing anomalies, most of humanity remains unaware. Life continues according to familiar patterns. People notice unusual weather, unexpected power outages, or small technical failures, but these are dismissed as isolated incidents, minor inconveniences rather than warnings of a larger cosmic shift. A small group of scientists and observers begins to recognize the patterns. Data from satellites, probes, and ground-based instruments reveal the undeniable reality. The universe itself is changing, and Earth is responding. Correlations appear where none should exist, suggesting a link between distant interstellar space and local phenomena. Yet, the broader society resists acknowledgement. Governments prefer stability in perception. Media emphasizes sensational stories rather than slow, systemic changes. Economies depend on predictability. Admitting that the cosmos itself is altering would demand a fundamental reassessment of technology, science, and daily life. Denial becomes the default response. Reports from researchers are challenged, reinterpreted, or ignored. Conferences debate anomalies, but the conclusions remain cautious to the point of obfuscation. Public policy continues based on old assumptions, unaware that those assumptions are no longer valid. In laboratories and observatories, frustration grows. Instruments record results that defy classical expectations. Simulations fail to match observations. Calculations need constant correction. Yet publishing radical findings risks professional credibility and funding. Meanwhile, the subtle changes continue unabated. Biological systems, environmental processes, and technological networks slowly accumulate strain. Migration patterns drift further, satellite orbits require constant adjustment, and energy systems experience increasingly frequent micro-fluctuations. The paradox is clear, the evidence is all around, but perception lags behind reality. Awareness exists in pockets, denial dominates in the majority, and the universe continues to impose its quiet but inexorable influence. For those who observe, a profound tension emerges. Knowledge of the truth comes with anxiety and urgency. Action seems necessary, yet the means of response are limited. Civilization must adapt, but most of humanity is unprepared to confront a cosmos that is no longer stable. And in that gap between perception and reality, the slow, relentless process of change marches on. For decades, the changes remain subtle, imperceptible to the majority, measurable only by the most sensitive instruments. Yet those decades were enough to accumulate a new reality. The universe, once taken for granted, now defines Earth's conditions with silent authority. And now, the threshold is reached. This is not a moment of spectacular catastrophe. No explosions mark it. No alarms sound in the streets. Instead, the evidence is everywhere for those who know where to look. Satellite trajectories require constant correction beyond predictable norms. Seasons are out of rhythm. Ecosystems wobble in subtle yet measurable ways. Physicists realize the implications. The invisible medium that resists motion, the changing constants, the subtle energy losses, they are no longer reversible. The Earth cannot return to its previous equilibrium. The laws of motion and energy have been altered, and no intervention can restore the old stability. The term, irreversible, is whispered in labs, corridors, and conferences. It carries weight beyond scientific description. Every calculation, every mission plan, every projection must now account for an altered reality. The planet reacts quietly but persistently. Oceans shift in currents previously stable. Atmospheric patterns fluctuate unpredictably. Biological rhythms struggle to align. Human systems, technological, economic, social, experience mounting stress. Humanity adapts, but adaptation comes at a cost. Energy consumption increases. Engineering tolerances tighten. Every orbit, every circuit, every protocol is adjusted to cope with a universe that no longer behaves according to established principles. The awareness spreads slowly. Those who understand recognize a sobering truth. The world humans inhabit is fundamentally different from the one their ancestors knew. Civilization continues, but on a stage that has changed without permission, without warning, and without hope of restoration. This threshold is not a point of panic but of realization. Survival now depends on understanding, vigilance, and continuous adjustment. The old confidence and predictability is gone, replaced by a quiet acknowledgement of fragility in the face of cosmic impermanence. And beyond human perception, the universe continues. Stars shine. Galaxies spin. Motion persists. But everything now occurs in a medium that silently exacts a cost that can no longer be ignored or reversed. With the irreversible threshold crossed, Earth and humanity begin to settle into a new state, one that is different, fragile, and unfamiliar. The old rules no longer apply, and a new normal emerges, shaped by the subtle but unyielding changes in space and the fundamental constants of physics. Technological systems continue to function, but with constant adaptation. Satellites orbit with careful monitoring, energy grids adjust in real time to fluctuations, and factories maintain output through continuous recalibration. Civilization has learned to operate in a world where predictability is a luxury. Biological systems find a new rhythm. Migration paths, breeding cycles, and food webs slowly adjust. Some species flourish under the altered conditions, while others diminish or disappear. Ecosystems evolve incrementally, coping with changes too subtle for daily human awareness, yet significant across decades. Society adapts as well. Humans accept new patterns of work, transportation, and communication. Contingency planning becomes second nature. Education emphasizes flexibility, resilience, and problem-solving in an environment that is no longer stable. Cultural narratives shift subtly, acknowledging uncertainty as an enduring feature of existence. Psychologically, humanity is challenged. The realization that the universe itself is mutable creates both anxiety and awe. People confront the notion that what was once eternal, physical laws, celestial rhythms, and environmental constancy, is subject to change. Some feel fear, others fascination, but all adjust to live within the constraints of a subtly altered cosmos. Despite the subtlety of the changes, the consequences are profound. Every movement, every calculation, every plan now carries hidden costs imposed by the universe itself. Energy, time, and attention must be expended continuously to maintain the structures of life, society, and technology. Yet life persists. Earth spins on. Humanity adapts. The cosmos continues, silent and indifferent, reshaping itself and all within it. The new normal is neither catastrophe nor utopia. It is the steady persistence of life and civilization in a universe that has begun to move, subtly but inexorably, beyond the rules once taken for granted. And so, existence carries on, aware of its fragility, attentive to the quiet costs of motion, and resilient in the face of a cosmos that demands both adaptation and vigilance. Beyond the new normal lies the silent future. A future defined not by dramatic catastrophes, but by the quiet persistence of a universe in slow flux. Earth continues to spin, civilizations endure, and life adapts, but the cosmos has permanently altered the stage upon which all existence plays out. Time itself, once assumed to be an unbroken flow, is now understood as relative not only in motion but in stability. Subtle shifts in physical laws and energy dissipation shape the environment at scales both immense and intimate. Human perception cannot feel these changes directly, but instruments, data, and careful observation reveal a steady transformation. Society has learned to coexist with uncertainty. Technology functions with adaptive protocols. Ecosystems adjust to new rhythms. Humanity recognizes the limits of control and the necessity of resilience. Predictability is no longer assumed, adaptability is prized above all. Philosophically, the lesson is profound. The universe is not a static stage. It is an active participant, exerting quiet influence over every process, from the orbit of satellites to the cycles of life. What was once thought eternal, the laws, the constants, the very rules of motion, is now a framework subject to slow alteration. Survival is no longer a matter of power alone, but of awareness, responsiveness, and continual effort. Despite the challenges, life endures. The earth rotates, plants grow, oceans flow, and human civilization persists. There is no final catastrophe, no apocalyptic end, only the gradual unfolding of a cosmos that demands respect, vigilance, and adaptation. The silent future is vast, unfeeling, and inevitable. Humanity must navigate it with understanding and humility, recognizing that progress and stability are temporary achievements in a universe that continues to move and change quietly, inexorably, and without pause. In this new cosmic reality, existence itself is a testament to perseverance. To live is to adapt. To endure is to acknowledge that the universe, once thought constant, is now alive with subtle motion, and that life on Earth must move with it, patiently, attentively, and forever into the silent future.